Hello everyone, welcome back to Introductory Chemistry, and this is week 1, video B. Let's carry on lecture 1 to learn something about atomic structure. The nuclear atoms are made of 3 fundamental particles. They are electrons, protons, and neutrons. If you look at here, if you imagine this is an atom, and here is the nucleus, which is quite small, and the electrons are very far from the center of the atom. So if you imagine the atom is like a football stadium, the nucleus is more like a garden pea in the center, somewhere in the picture that you won't be able to see. The electron will be more like a fly, and flying around the stadium, but much smaller, with annoying noise. Okay, let's look at some concepts in terms of atomic number, mass number, ions, and isotopes. Okay, let's make a call to Professor Dave.
Hey, it's Professor Dave. Let's talk about nuclide symbols. We know that atoms have a tiny nucleus with positively charged protons and neutrons which have no charge, as well as negatively charged electrons that are some distance away from the nucleus. Every element is a combination of some number of these 3 particles. The one that determines which element an atom belongs to is the proton. 1 proton means hydrogen, 2 is helium, 3 is lithium, and so forth. So an element has an atomic number, which refers to the number of protons in the nucleus. Each atom also has a mass number. While only protons count for atomic number, both protons and neutrons count for mass number because protons and neutrons are each about 1 atomic mass unit. Electrons are so much less massive than protons and neutrons that we ignore them when we look at mass. So mass number is really just the number of particles in the nucleus. If an atom has 6 protons and 6 neutrons, it is an atom of carbon-12. Here, the number is referring to the mass. Carbon atoms always have 6 protons. If they didn't, they wouldn't be carbon. When we represent an atom, we use a nuclide symbol. This will consist of 1 or 2 letters that abbreviate the element. If 1 letter, it's capitalized. If 2, the first is capitalized and the second is not. To the bottom left, we sometimes put the atomic number, which, as we said, is the number of protons in the nucleus. This is kind of redundant because the type of element implies the number of protons, but sometimes we do it anyway. To the upper left is the mass number. This is not redundant because atoms of a given element can have different masses due to differing numbers of neutrons. These are called isotopes of a given element. Remember that the mass number is the number of protons plus the number of neutrons, which means that the number of neutrons in an atom is the mass number minus the atomic number. And to the upper right, if the atom is an ion, meaning a particle with electrical charge, the charge will be listed here. If the number of protons and electrons in an atom are the same, the positive and negative charges cancel out and it will be a neutral atom. But if it gains an electron, there will be 1 more negatively charged electron than there are protons, so the atom will have an overall -1 charge. If instead it loses an electron, it will lose a negatively charged particle, and there will now be 1 more positively charged proton than there are electrons, so it will have an overall +1 charge. So particles with differing numbers of protons are different elements. Particles of a given element with differing numbers of neutrons are different isotopes. And particles of a given element with differing numbers of electrons are different ions. If we look at the periodic table, all the elements are arranged by atomic number. 1 proton in the nucleus all the way to 100 and more. Then we can look at the atomic masses. But if the atomic mass is the sum of the particles in the nucleus, shouldn't they all be whole numbers? There aren't any fractions of a neutron after all. The reason they have decimals is because they are average atomic masses for all the isotopes of that element. Remember that isotopes have differing numbers of neutrons. The average has to reflect the relative abundance of each isotope. For example, chlorine can be chlorine-35 or chlorine-37. All chlorine atoms have 17 protons, but they can have either 18 or 20 neutrons. However, about 75% of chlorine atoms are chlorine-35, and only 25% are chlorine-37. So the average is not 36 because there is much more chlorine-35 than 37. So we have to do some math. Multiplying each mass number by a fraction of 1 that represents its abundance, and then adding these up, gives us a more accurate number for the average mass of all chlorine atoms. So on the periodic table, we have average atomic masses, but any individual atom will have its own mass number, which must be a whole number. Let's check comprehension.
Thanks very much to Professor Dave for explanation of atomic number, mass number, ions, and isotopes. Here, let's review some important knowledge. So here, the atomic weight of an element, and the atomic weight, here we have an equation you should remember that is likely to appear in your exam papers. So the atomic number equals isotope mass multiplied by fractional isotope abundance. And here is a sign of summary. For example, atomic number of carbon equals 0.9893, which is the abundance of carbon-12. So then multiplied by 12 and plus the abundance 0.011. So here we do a rounding, multiplied by the mass of carbon-13, which is 13.000335. To make a calculation, that equals 12.01 AMU. So please remember, atomic weights are given in units of AMU. Okay, quiz time. How many protons and how many electrons in oxygen-18 atom? The answer is A. So here you have 8 protons, and the atom is neutral, so it has 8 electrons. Thank you very much for your attention. Thank you.